Hello everyone, I'm Adam. In this problem, for the curve that's generated by our polar equation, which we have as r equals 7 divided by 4 plus 8 times sine of theta, which we know is the curve of a conic section of some sort, we're going to try and find the eccentricity and then the distance from the pole to the directrix to start with. Then we're going to sketch the curve and then confirm our results with a graphing utility. So to start with, let's look at one of the general forms of a conic section in polar form. So we have r equals to e times d, where e, which is a positive number, is our eccentricity, and the absolute value of d is the distance from the focus at the pole to the directrix. So to start with, what we're trying to find is these values e and d. And then that's divided by 1 plus e times the sine of theta. So to get started, take it one piece at a time, we'll find our eccentricity and our distance. We're going to take our original polar equation and try to write it so it's in the form that looks like this. So coming here, so our r, well, what's kind of our guiding light? Well, if we look at this, I don't know what e and d is or what e times sine of theta is going to be, but I know a constant value here has to be 1. And I see the 4 up here. So what can I do to get a 1 there? Well, I can divide top and bottom by 4 would give me a 1 in that 4's position. So r is going to be equal to dividing top and bottom by 4. The top will be 7/4, and the bottom will be 1 plus 8 divided by 4 is 2 times sine of theta. Okay, so just looking at the denominator, that's exactly in the form that we want here. 1 plus some number times sine of theta, where that number, say, is 2. Okay, so that's our eccentricity. Now, the eccentricity also being greater than 1 tells us something else. If the eccentricity is greater than 1, that tells us the type of curve we're going to have is a hyperbola. So there we have our eccentricity is 2, and we know the sketch of our curve is going to be a hyperbola. Now let's pay attention to the top part, because we need e times d, namely to get the d number. Well, this is equal to, if we want to write the top as e times d, well, and e is 2, we can write 7/4 as 2 times 7/8, and our bottom is still 1 plus 2 sine of theta. And so that implies that our d, the distance from the pole to the directrix, is 7/8. Okay, so we found those two things. Now what we want to do is try to develop a sketch of this curve. Well, going back to the basic form of our polar equation, we see the plus here, which is what we have in our equation. The plus says that we have a horizontal directrix, and namely, our directrix is going to be the line y equals d, or the line y equals d, which is 7/8. So with that, we'll start by sketching our curve. So we're going to sketch in our directrix at the line y equals 7/8. So from our origin coming up about 7/8, and horizontal line through that, which will be our directrix. Okay. And so that's our directrix, the line y equals 7/8. Now what's important about that? Well, the fact that that's horizontal, that tells us that our transverse axis, which is perpendicular to that, is going to be running along our line, or y-axis, or line theta equal pi over 2. So the vertices of this hyperbola, we know we're going to be somewhere on this line. So we can find those vertices simply by taking the values of pi over 2 and 3 pi over 2, plugging into our function, and seeing what points we get on that line. So let's take a look at that. So we said we're going to take the value of pi over 2 and plug it into our original function, which is f of theta is equal to r. To clarify our symbols, so r is f of theta, we want to find f of pi over 2. So into our original function, that's 7 divided by 4 plus 8 times sine of pi over 2 is 1. So that's 7 over 4 plus 8. That gives us 7/12. So let's come over here and plot that. So the first vertex is going to be at angle pi over 2, distance r 7/12. So 7/12, which is just a little bit more than a half. So between 0 and 1. So we have our first vertex. And that's at our point r is 7/12. Angle theta is pi over 2. And we said we'll find f of 3 pi over 2, which is equal to 7 divided by 4 plus 8. And sine at 3 pi over 2 is -1. So this is equal to 7 over 4 plus -8, and it gives us -4. Okay, so -7/4. So our second vertex, if we go at angle 3 pi over 2, -7/4, or up in the opposite direction. So from our origin, we're just going to come up 7/4, which is 1 3/4, or 1.75. So at 1 and 0.75. Okay, so we have our next vertex. R is -7/4, angle 3 pi over 2. All right, so we're kind of getting there. So we know that the hyperbola is going to go through these vertices, going to be opening upwards this way and downwards that way. The next thing we need to find is what we're eventually going to do is find the asymptotes that have to go through the center. So that's what we need to find now, is the center point. So the center point, from what we know about hyperbolas, is the point that is centered between these two vertices. Okay, so the point that's equidistant between these. So there's a couple of different ways we can do this. What we're going to do is we'll just find the distance between this point, and then take that divided by 2 would give us the distance that's going to be in the middle. So what did we just say? So we're going to find our center here. Okay. So the center, we want the distance from this top vertice to the bottom. So the distance of this is just going to be +7/4 from the origin. So we can take 7/4 minus 7/12. So 7/4 minus 7/12 is 7/6. So that's the distance from the top to the bottom, but we want the midpoint. So what we're going to do is multiply that, or divide it by 2, multiply it by a half. So 7/6 times 1/2 gives us 7/12. So what does that mean? That means if we say go from our bottom vertex and go up 7/12, that'll get us to the center point. And so let's label that. So from the bottom vertex up 7/12, or 7/12 plus 7/12 is 7/6. So we can measure that from the origin if we want. Okay, so there's our center point. Now let's go ahead and label that to help us. So our center, which with a hyperbola we're used to thinking of as HK, that's going to have x coordinate 0, since it's on our y-axis, and y coordinate, say 7/6. And we also get one more thing about a hyperbola. The distance from the center out to the vertices, or our number a, is this 7/12. So a is 7/12, which is going to help us out when we find our hyperbola, or the equation of it. So we have a is 7/12. Now, or not the equation of the hyperbola, the equation of our asymptotes. We have a, we want to find b. So we know that b squared is equal to a squared times e squared minus 1. So fitting this in, so b squared is equal to, say, 7/12 squared times our e squared, which is 2 squared minus 1. So to keep things in exact form for now, so 7/12 quantity squared times 2 squared minus 1 is 3 is going to give us, say, 49/48, which tells us that b, taking the square root of both sides, b being a distance, so just taking the positive square root, will be 7 over the square root of 48. Okay, now what can we do with this? Well, now what we want to do is find our asymptotes. Right. And our asymptotes are going to be at the lines y equal to k plus or minus a over b times x minus h. So plugging in our h, k, a, and b, we can get this line. And we'll have two of them. So we'll take y is equal to k, right, which is the y coordinate of our center, 7/6, and then we'll do plus, so a over b. So a is 7/12 divided by 7 over the square root of 48. So plugging that in, and we'll take a decimal approximation, since this is going to represent our slope. So that's going to be approximately, say, 0.6 times x minus h, where h is 0, so this is just 0.6 times x. Now, since we approximated that, let's make these little approximation symbols. So we'll have one asymptote there, and the second asymptote will be y, will be approximately 7/6 minus 0.6 times x. Okay, now all we have to do is sketch those in, and we'll be ready to sketch our hyperbola. So looking at our asymptotes, we'll start with the first one. So y-intercept at 7/6, slope at 0.6, meaning if we go over 1, we'll go up approximately 0.6. So from the center, over 1, up about 0.6. So I have a point there. Now, we'll just go ahead and mark the point while we're at it. For our second asymptote, we have slope negative 0.6. So we'd be going over and up 0.6, over to the left, up 0.6. Okay, so our two asymptotes, going through our 2 points, the center and the ones we just plotted. Okay, now I think we're ready to finish it up. So what we're going to have, so at our two vertices, following along with our asymptotes, our hyperbola is going to look something like this, coming through a vertex, going along asymptote this way, and out that way, and from our vertex, going along our asymptote there, and our asymptote there. So there we go. There's the hand sketch of our hyperbola. Now what we want to do is just confirm that with a graphing utility. So taking our graphing utility and first making sure that our mode is in polar mode, we'll enter in our equation in its original form, 7 divided by quantity, 4 plus 8 times sine of theta, and we'll take our window, theta min from 0 to the theta max of 2 pi, and make our theta step 0.1, x min from negative 3 to x max of 3, and x scale of 1, and y min from negative 2 to y max of 5, and y scale of 1. And then if we press graph, in part this will be sketched out. So we see the bottom part of the hyperbola being sketched, then our two asymptotes, then the top of the hyperbola, and then the remaining of the bottom. So there we go. Thank you very much.